Welcome. We will continue our discussion of method of substitution. It's possible that the function you are trying to integrate is a sum of several different terms, and you might have to use different substitutions for different terms. So that's what happens in our next example, where we have to integrate x over square of the quantity x squared plus 1 minus x squared over the quantity x cubed plus 2. Our rule of thumb suggests that the first term I should try using substitution u equals x squared plus 1. I'll find du. Du is 2x dx. We have x dx in the numerator. I divide both sides by 2. X dx is du over 2. If I rewrite the first term, the denominator is u squared. The numerator is du over 2. So it's the integral of 1/2 du u power negative 2. Since the exponent is not negative 1, I can use the power rule. If I add 1 to the exponent, negative 2 plus 1 is negative 1. And antiderivative is 1/2 times u to the negative 1 over negative 1, and then plus the constant of integration. Because we'll be doing more than one integral, I will call this C1 to avoid confusion. We want to rewrite this in terms of the original variable x. So I'm going to substitute x squared plus 1 for u, since what I have here is u to the power negative 1 over negative 2. If I write that in terms of x, I get negative 1 over 2 times x squared plus 1 power negative 1 plus this constant of integration. The second term in the original problem was minus x squared over x cubed plus 2. Our rule of thumb says w equals x cubed plus 2 is a substitution to use. I want to use a different letter to avoid confusion with u we used for the first term. dw is 3x squared dx. In the numerator I have x squared, so I can write that in terms of dw. The second term becomes dw over 3 divided by w. So it's 1/3 dw over w. So an antiderivative will be 1/3 ln of absolute value of w plus a constant of integration, which I'm calling C2 to avoid confusion with the other constant of integration. Again, I need to go back to the original variable x, so I'm going to substitute x cubed plus 2 for w. So I get 1/3 ln of absolute value of x cubed plus 2 plus the constant of integration. The original problem asked for the integral of the difference between this and this, so the answer will be this minus this, and we can combine the two constants c1 and c2 into one. Since we don't really know what c1 and c2 are, all we can say is that it's c1 minus c2, just some constant of integration. So that gives me negative 1/2 x squared plus 1 power negative 1, which I've written as a fraction, minus ln of absolute value of x cubed plus 2 over 3, plus constant of integration. This concludes the discussion of this example.